So, let's try to approach electrochemistry. What electrochemistry literally means? Well, we are referring to, with this term, electrochemistry, that science whose final aim is to connect the chemical reaction and the generations of electricity. For instance, if we can imagine what actually we have, for instance, in our smartphone or in any type of electrical devices, how we are able to provide a certain number of functions due to the creations of a current, well, in an application that is not stationary, we are able to take phones and go everywhere. And the point is basically that we are exploiting chemical energy, chemical reaction, in order to create electricity. The basic concept on which the entire electrochemistry is based, it's this one, and it's simple. We want to take reagent in a state that is not the state that the reagent, that chemicals preferred. And in this way, they always want and try to tend and try to reach a more stable state. So what we want to do in a start, in a battery, is use chemicals and freeze this chemical in a situation that is not the more stable. In this way, that chemicals try to react with redox reactions, reaching the final more stable state. And doing this, we have redox reactions and the release of electrons that can be collected from an external circuit and used in order to drive an electrical device. So this is the final aim. We want to take chemicals, and these chemicals, in that configurations, the configurations before the discharging process, are not stable, and spontaneously they want to reach a new state. And doing this, we have a redox reactions and the generations of a current. Knowing this, we can say that the electrochemistry can be subdivided within, speaking about cell, galvanic cell, and electrolytic cell. What does it mean? So, what is a galvanic cell? Galvanic cell and electrolytic cell. So, a galvanic cell is a cell in which what we are doing is exploit chemical energy in order to obtain electricity. So, from chemical energy, we want to obtain electricity. So we are using reagents in a non-stable state, and due to our redox reactions, we are creating electricity. What does it mean? That since we are using reagents that in that state are not stable, they are not comfortable with their, in that moment, own situation. And so want to reach something different, the creation of new product, a new stable state. And doing this, they create electricity. And so when we are dealing with a galvanic cell, we are dealing with spontaneous chemical reaction. But sometime, and this it will be extremely important speaking about secondary battery. What does it mean? So basically the difference, we will see this aspect, between a primary battery and a secondary battery is that a primary battery cannot be recharged. So when the reagents are finished and are completely converted in a different product, we are not able anymore, anyway, to reobtain the starting condition. Whereas in secondary battery, we are able to use electricity in order to repristinate the original situations and passing again from the product, just already created in a spontaneous way, again in reagent, the starting reagent. So we have the spontaneous discharging and we have the recharging that is not spontaneous. Because if in a battery, in a galvanic cell, we want a spontaneous reaction in order to pass from chemical energy to electricity, if we want to recharge this type of device, since we have already used the potential energy inside the chemical reaction, we have already consumed this energy in a spontaneous process. Well, if we want to go in the opposite direction, so repristinate the reagent, but the reagent existing at the very beginning in a non-stable state, and so what we need to do is fight the spontaneous tendency of this reagent to reach the product, and so we need to provide electricity. We need to provide electricity because in an electrolytic cell, that is the opposite situation, we want to promote a non-spontaneous reaction. And so we can use electricity in order to obtain chemical energy. For instance, when we have a battery, at the very beginning we have the discharging, and so the spontaneous creations of product, we can say that from an energetical point of view, if this is the free energy of the starting state, and this is the free energy of the final one, we have a pathway like that, so reagent and product, we are reaching a smaller value of free energy. But when we want to repristinate the original situation, we need to apply on the two electrodes a potential difference, a current, with a potentiometer, for instance. And we are speaking in this case about electrolytic cell, because we want to promote the opposite direction. We want to repristinate this when it's obviously possible. And so what does it mean? That we need to consume energy because the reactions in this case is not spontaneous anymore. In these directions it's spontaneous, but not in the opposite one. So this is just a first look about the difference between a galvanic cell and the electrolytic cell. When we want the conventional battery that we have in our smartphone, in general during the discharging process, they were acting as a galvanic cell. Whereas when we want to recharge, for instance, a secondary battery, a rechargeable batteries, or in general when we want to promote a chemical reaction that is not spontaneous at all, we need to consume energy in the forms of electricity. And in this case, we are speaking about electrolytic cell. From chemical to electricity, galvanic cell. From electricity to chemical energy, electrolytic cell.